what I want to talk to you about today is changing these problems that look like this that we've been doing in class with the kits into a more algebraic representation for it. So to begin, I have two pawns and a block that's worth 3. And then I have my brick wall. And then I have 2 blocks that together are 15. So this block we said was 3, and this block we said was 10, and this one 5. And so when we solve equations like this, we're looking to see what we can take from both sides, because we have to keep it balanced, because we're balancing this equation or keeping it equal. And so when I look here on the left, I see that I have 2 pawns, but I don't have any pawns over here, so I can't mess with those. When I look on the left, on the other left again, I see that I have this constant value of 3, and here I have a value that's equivalent to 15. Well, since my goal is to get these 2 pawns, or to get a pawn by itself, just one, I need to start moving things away from it. So my first thing I'm going to do is I'm going to move this 3 away. So if I take a 3 from the left, I need to take a 3 from the right. So my 15 becomes a 12. And so now I have 2 pawns that are equal to 12, but I don't want 2 pawns equal to 12, so I have to divide this in half. And if I divide this in half so I get a single pawn, I have to do the same thing in here. And if I divide 12 in half, that becomes 2. So or 6 rather. So I see that a pawn is equal to 6. So I'm going to put that x equals 6 up here. Right? But you're not always going to have a kit, nor are you going to be able to, draw these things and so forth. So let's look at what the problem would look like if we wrote it out algebraically. So I'm going to model the problem the way it was, and then we'll go through it step by step so that we can talk about what it was that we did as we went through the problem. Okay, so if I rewrite this problem, these 2 pawns that I don't know, I'm going to call those 2x. And then I'm putting a 3 with it, so I'm adding 3 to it. Here I have my brick wall, which is my equal sign, so nothing's going to get from one side to the other without doing it to both sides. And then I have my 15. So remember, we couldn't do anything with the x's first off, but we could mess with the 3's. So we subtracted 3 from each side. So I write it like this. Notice that I've lined up my 3's underneath each other, and I've lined the 3 up with the 15. Because when we took the 3 off of here and the 3 off of here, what I was left with was my 2 pawns now being equal to no longer 15, but 12. So that's what I see here, and that's what happens here. So 2x comes down. I don't write anything here because it's just gone away, equals 12. Everything's lined up nicely. And now I remember that I don't want 2, so I'm thinking, okay, I don't want 2 x's. Well, 2 divided by 2, that's 1. And if I divide the left side by 2, I need to divide the right side by 2. And so I'm left with x equaling 6. Now I want to check this. And so what I do to check it is I go back to my original equation, which was 2x plus 3 equals 15. And since x was equal to 6, every time I see an x, I'm going to replace it with a 6. So 2x, of course, means 2 times of x. So I'm going to do 2 times of 6 plus 3 equals 15. And 2 times 6 is 12. 12 plus 3 equals 15. And since 15 does equal 15, that's my check. 15 equals 15.